NEC Article 300.3 Cone addresses the installation of conductors of different systems within the same raceway. Specifically, it permits conductors of circuits rated 600 volts, nominal or less, encompassing both alternating current and direct current circuits, to occupy the same equipment wiring enclosure, cable, or raceway. This provision offers flexibility in electrical installations, but it's crucial to understand the underlying requirements and considerations to ensure safety and code compliance. The primary condition for allowing conductors of different systems in the same raceway is that all conductors must have an insulation rating equal to at least the maximum circuit voltage applied to any conductor within the enclosure, cable, or raceway. This requirement is paramount for preventing insulation breakdown and potential short circuits between conductors operating at different voltage levels. For instance, if a raceway contains both a 120-volt circuit and a 277-volt circuit, all conductors within that raceway must have an insulation rating of at least 277 volts. This ensures that the insulation can withstand the highest voltage present, providing a sufficient safety margin. While the NEC permits the mixing of conductors from different systems, there are practical considerations to bear in mind. Firstly, it's essential to maintain clear identification of the conductors to avoid confusion during maintenance or troubleshooting. Color coding is a common method for identifying different circuits and voltage levels. For example, using black for 120 volts phase conductors, red for 277 volts phase conductors, and blue for 480 volts phase conductors can help electricians quickly distinguish between the different systems. Secondly, it's crucial to ensure that the raceway fill does not exceed the maximum allowable limits specified in the NEC. Overfilling a raceway can lead to overheating of the conductors, which can degrade the insulation and increase the risk of electrical faults. The NEC provides detailed tables and calculations for determining the maximum number of conductors allowed in a given raceway size based on conductor size, insulation type, and raceway type. Thirdly, it may be necessary to install a barrier or divider within the raceway to physically separate the conductors of different systems. This is particularly important when dealing with sensitive electronic equipment or when there's a concern about electrical interference between circuits. A barrier can help to minimize the risk of noise or harmonics from one circuit affecting the performance of another. In the context of installing conductors from two separate service equipment enclosures in the same conduit, the principles of NEC Article 300.3 cones still apply. Provided that the voltage rating of all conductors is adequate and that the raceway fill and other installation requirements are met, it is permissible to run conductors from multiple service enclosures in the same conduit. However, it's crucial to carefully consider the potential for electrical interference and to take appropriate measures to mitigate any risks. For example, if one service enclosure feeds a sensitive electronic load while the other feeds a high-power motor, it may be advisable to install a barrier between the conductors to prevent noise from the motor circuit from or affecting the electronic equipment. Furthermore, it's important to ensure that the grounding and bonding systems for the two service enclosures are properly coordinated. The NEC requires that all service equipment be properly grounded and bonded to ensure a low impedance path for fault currents. If the grounding and bonding systems are not properly coordinated, it can lead to circulating currents and other problems that can compromise the safety and performance of the electrical system. Here's a more detailed breakdown of the key considerations when applying NEC Article 300.3 cone. Firstly, insulation rating. All conductors within the same raceway must have an insulation rating equal to or greater than the highest voltage present in any circuit within that raceway. Common insulation types include THHN, THWN, and XHHW, each with different temperature and environmental ratings. Select the appropriate insulation type based on the specific conditions of the installation. Secondly, raceway fill. The NEC specifies the maximum allowable fill for different types of raceways based on the cross-sectional area of the conductors and the raceway. Exceeding the allowable fill can lead to overheating and insulation damage. Use the NEC tables and calculations to determine the appropriate raceway size for the number and size of conductors being installed. Thirdly, conductor identification. Clearly identify all conductors to avoid confusion during maintenance or troubleshooting. Color coding is a common method, but other methods, such as labeling or tagging, may also be used. Ensure that the identification method is durable and easy to read. Fourthly, barriers and dividers. Consider installing a barrier or divider within the raceway to physically separate conductors of different systems, especially when dealing with sensitive electronic equipment or high-power loads. Barriers can help to minimize electrical interference and improve the overall performance of the electrical system. Fifthly, grounding and bonding. Ensure that the grounding and bonding systems for all service equipment and circuits are properly coordinated. The NEC provides detailed requirements for grounding and bonding to ensure a low impedance path for fault currents. Failure to properly ground and bond the system can lead to dangerous voltage potentials and increase the risk of electrical shock. Sixthly, directing factors. When multiple current-carrying conductors are installed in the same raceway, it may be necessary to apply directing factors to the allowable ampacity of the conductors. Directing factors account for the increased heat generated by multiple conductors in close proximity. Consult the NEC tables to determine the appropriate directing factors for the specific installation conditions. Seventhly, ampacity. The ampacity of conductors must be suitable for the application. In general, the ampacity of the conductors must be greater than or equal to the non-continuous load plus 125% of the continuous load. Standard conductor sizes and their ampacities are listed in NEC Table 310.16. Eighthly, voltage drop. Voltage drop can impact the performance of equipment. Conductors must be sized so that the voltage drop does not exceed 3% for feeders or 5% for the combined feeder and branch circuit. Ninthly, short circuit current rating. Equipment must have a short circuit current rating adequate for the available short circuit current at its terminals. The available short circuit current can be determined by a short circuit study. Tenthly, conduit type. Select the conduit type appropriate for the application. Examples of conduit types are rigid metal conduit, intermediate metal conduit, electrical metallic tubing, and flexible metal conduit. Each has different uses and installation methods. 11th, installation methods. Use the correct installation methods. For example, supports must be placed within 3 feet of boxes, conduit must be properly reamed, and lock nuts must be tightened properly. 12th, labeling. Label equipment clearly. Panel boards should have a typewritten directory of circuits. Equipment should be labeled with its voltage, amperage, and phase. 13th, working space. Sufficient working space must be provided around electrical equipment. NEC Section 110.26 specifies the amount of working space required. 14th, enclosure type. Select the correct enclosure type for the environment. For example, an M3R enclosure is rainproof and an M4X enclosure is watertight and corrosion resistant. 15th, overcurrent protection. Install overcurrent protection sized to protect equipment and conductors. Fuses and circuit breakers are examples of overcurrent protective devices. Now, let's delve into some practical examples to illustrate the application of NEC Article 300.3 cone. Consider a scenario where you're installing a subpanel in a detached garage fed from the main service panel in a house. The subpanel will supply both 120 volts lighting and receptacle circuits, as well as a 240 volts circuit for a welder. In this case, you can run all the conductors, including the 120 volts neutrals, 240 volts and grounded conductors, and the grounding conductor, in the same conduit between the house and the garage. However, all conductors must have an insulation rating of at least 240 volts, and the raceway fill must be within the allowable limits. Another example involves installing conductors for a photovoltaic system on the roof of a commercial building. The photovoltaic system includes both direct current conductors from the solar panels and alternating current conductors from the inverter. According to NEC Article 300.3 cone, you can run both the DC and AC conductors in the same raceway provided that all conductors have an insulation rating of at least the maximum voltage present in either the DC or AC circuits. In addition, it's important to consider the potential for induced currents in the metal raceway due to the DC conductors. To mitigate this risk, the NEC requires that the metal raceway be bonded to ground at both ends. A third example involves a data center where you're installing conductors for both power circuits and control circuits in the same cable tray. The power circuits operate at 480 volts, while the control circuits operate at 24 volts direct current. In this case, you can run both the power and control conductors in the same cable tray, provided that all conductors have an insulation rating of at least 480 volts. However, it's important to consider the potential for electrical noise from the power circuits to interfere with the control circuits. To minimize this risk, you may need to use shielded cables for the control circuits or install a physical barrier between the power and control cables. It's also important to note that NEC Article 300.3 code is not the only relevant code section when installing conductors from different systems in the same raceway. Other code sections, such as NEC Article 310.15, which covers conductor ampacity, and NEC Article 250.146, which covers equipment grounding, may also apply, depending on the specific installation. Therefore, it's crucial to consult the entire NEC to ensure compliance with all applicable requirements. In summary, NEC Article 300.3 code permits conductors of different systems to occupy the same raceway provided that all conductors have an adequate insulation rating and that other installation requirements are met. This provision offers flexibility in electrical installations, but is essential to carefully consider the potential risks and to take appropriate measures to mitigate them. By understanding the underlying principles of NEC Article 300.3 code and consulting the entire NEC, you can ensure the safety and reliability of your electrical installations. Let's also consider the following aspects to enrich the comprehension and practical application of NEC Article 300.3 code. Firstly, harmonic currents. In systems with nonlinear loads, such as electronic equipment, harmonic currents can be a significant concern. These currents can cause overheating of conductors and equipment, as well as voltage distortion. When installing conductors from different systems in the same raceway, it's essential to consider the potential for harmonic currents and to take appropriate measures to mitigate their effects. This may involve using oversized neutrals, installing harmonic filters, or separating the conductors of harmonic-sensitive circuits from those of other circuits. Secondly, surge protection. Transient voltage surges caused by lightning strikes or switching events can damage electrical equipment and compromise the insulation of conductors. When installing conductors from different systems in the same raceway, it's advisable to install surge protection devices to protect against these transients. Surge protection devices should be installed at the service entrance and at any subpanels or equipment that are particularly susceptible to surges. Thirdly, electromagnetic interference. Electromagnetic interference, or EMI, can disrupt the operation of sensitive electronic equipment. EMI can be caused by a variety of sources, including radio transmitters, industrial equipment, and even other electrical circuits. When installing conductors from different systems in the same raceway, it's important to consider the potential for EMI and to take appropriate measures to mitigate it. This may involve using shielded cables, installing filters, or separating the conductors of sensitive circuits from those of other circuits. Fourthly, communications circuits. Communications circuits, such as telephone lines and data cables, are particularly susceptible to interference from power circuits. When installing communications circuits in the same raceway as power circuits, it's essential to follow the requirements of NEC Article 800, which covers communication systems. Article 800 specifies the minimum separation distances between communications circuits and power circuits, as well as other requirements for minimizing interference. Fifthly, fire stopping. When raceways pass through fire-rated walls or floors, it's essential to install fire-stopping materials to maintain the integrity of the fire barrier. Fire-stopping materials are designed to prevent the spread of fire and smoke through the openings created by the raceways. The NEC requires that fire-stopping materials be listed for the specific type of raceway and the specific fire rating of the wall or floor. Sixthly, accessibility. Electrical equipment and conductors must be accessible for maintenance and repair. The NEC specifies the minimum working clearances required around electrical equipment, as well as other requirements for ensuring accessibility. When installing conductors from different systems in the same raceway, it's important to ensure that all conductors and equipment are accessible for future maintenance and repair. Seventhly, future expansion. When designing an electrical system, it's important to consider the potential for future expansion. This may involve installing spare conduits or raceways to accommodate future circuits. When installing conductors from different systems in the same raceway, it's advisable to leave some spare capacity for future expansion. This will make it easier to add new circuits in the future without having to replace the entire raceway system. Eighthly, documentation. Proper documentation is essential for the safe and efficient operation of an electrical system. Documentation should include wiring diagrams, panel schedules, and other information that is useful for troubleshooting and maintenance. When installing conductors from different systems in the same raceway, it's important to document the installation thoroughly. This will help to ensure that future electricians can easily understand the system and make any necessary repairs or modifications. Ninthly, local amendments. It's important to be aware of any local amendments to the NEC that may be in effect in your area. Local amendments are modifications to the NEC that are adopted by local jurisdictions to address specific local conditions or concerns. These amendments can vary widely from one jurisdiction to another, so it's essential to check with your local electrical inspector to determine what amendments are in effect in your area. Tenthly, qualified personnel. Electrical work should only be performed by qualified personnel who are trained and experienced in the installation and maintenance of electrical systems. Qualified personnel are familiar with the NEC and other applicable codes and standards, and they have the skills and knowledge necessary to perform electrical work safely and correctly. When installing conductors from different systems in the same raceway, it's essential to use qualified personnel to ensure that the work is performed in accordance with all applicable requirements. In addition to these considerations, it's also important to remember that the NEC is a minimum standard. It represents the minimum requirements for safe electrical installations, but it does not necessarily represent the best practices. In some cases, it may be advisable to exceed the requirements of the NEC to improve the safety, reliability, or performance of an electrical system. For example, you may choose to use larger conductors than required by the NEC to reduce voltage drop or to improve the system's ability to withstand harmonic currents, or you may choose to install more surge protection devices than required by the NEC to provide better protection against transient voltage surges. Ultimately, the goal of any electrical installation should be to create a safe, reliable, and efficient system that meets the needs of the user. By understanding the requirements of the NEC and by considering the specific conditions of the installation, you can design and install an electrical system that meets these goals. These detailed points should provide a comprehensive understanding of the considerations and requirements surrounding NEC Article 300.3 when installing conductors from separate services in the same conduit. Always prioritize safety, compliance, and best practices in every electrical installation.